How do you pick TensorFlow optimizer and loss functions? Imagine you're building a machine learning model and want it to learn as efficiently as possible. Choosing the right optimizer and loss function is a key step in that process. But how do you decide which ones to use? Let's break it down together. First, think about the type of problem you're solving. If you're working on a classification task, like telling whether an email is spam or not, you'll want a loss function that measures how well your model predicts categories. Common choices are categorical cross-entropy for multiple classes or binary cross-entropy for two classes. For regression tasks, where you're predicting continuous values like house prices, mean squared error or mean absolute error are popular options. Next, consider the size and complexity of your dataset. If your dataset is small and simple, a basic optimizer like stochastic gradient descent may work well. But if you're dealing with large, complex datasets or deep neural networks, adaptive optimizers like Atom or ARMSPprop are better because they automatically adjust learning rates during training. These optimizers help your model learn faster and more reliably. Think about your model's architecture. More complex models with many layers and parameters often benefit from adaptive optimizers that handle varying gradient patterns. Simpler models with fewer parameters might perform just fine with stochastic gradient descent, especially if you're aiming for quick results. Memory and computational resources also matter. Some optimizers, like Atom, requiring more memory because they keep track of additional information like moment estimates. If you're working with limited hardware, you might prefer simpler optimizers to save resources. Now about loss functions. They tell your model how far off its predictions are from the true data. For classification, cross-entropy loss functions are standard because they work well with probability outputs. For regression, mean squared error is common because it penalizes larger errors more heavily, helping your model focus on accuracy. It's also good to match your loss function with your output layer's activation. For example, if your last layer uses softmax activation, categorical cross-entropy is the best fit. If you're using a linear output for regression, mean squared error makes sense. Lastly, don't be afraid to experiment. Starting with the default choices like Atom Optimizer and a suitable loss function for your task is a solid plan. But trying different combinations can help you find the best setup for your specific problem. Understanding how to pick the right optimizer and loss function is fundamental for building effective models. TensorFlow makes this easier by providing a variety of built-in options, so you can focus on your application's goals. Remember, the choices you make here influence how well your model learns and performs in real-world situations.